Keithan, special guest, and my son Zeke, and Brody Freeland. So we got f of x equals x to the fourth minus 2x cubed plus 27x squared minus 2x plus 26. Hint, x equals I is a 0. This is a 0. So that means that x minus I is a factor. But according to page 291, and are you on page 291? Can you look at it? Page 291, the conjugates pairs theorem says that if you have one root, that if it's an imaginary complex root, like a plus bi, remember, complex numbers are of the form a plus bi, so if they have an imaginary part or a square root or an irrational number, then automatically its conjugate has to be, so page 291. So if we got x equals I, then x equals negative I has to be a root as well. So we also would have x plus I. All right, so we know that these two are going to be roots. So I'm going to go ahead and we got to get from x to the fourth down to x squared. So I'm going to go ahead and put I in the box for this one, for x minus I. And here we go. We got 1, negative 2. I'm going to go slow because I screwed it up in class. So let's don't screw it up here. Keithan's going to check my math. 27, negative 2, and 26. This one will be a little bit easier than the one we were doing in class. This is number 47. We should get a remainder of 0, though. We should get a remainder of 0 if it... And the reason I know it, because they told us that x equals I is a 0, right? So, drop the 1. 1 times I is I. Okay? And then we'll have negative 2 plus I. Okay? Then I'm going to multiply by what's in the box. So I'm going to take negative 2 plus I times I, which will give me negative 2I plus I squared. I squared becomes a what? Negative 1, right? This is going to become a negative 1. So we're going to have 27 minus 1, which is going to be 26 minus 2I. It already looks like it's going to work out because I got that 26 now. Now I'm going to go 26 times I, which is 26I. I'm going to go negative 2I times I, which will be negative 2I squared. The I squared will change this and make it plus 2. So those 2's will cancel, and now I have a 26I. Now I take 26I times I, gives me 26I squared. There it is. That's going to give me negative 26, which means it'll cancel, gets my 0 remainder. That worked out. We did it better this time. So x minus I, here we go. I'm going to circle that over here. X minus I is one of the roots. Okay? Now we're going to do negative I, because if we know I works, negative I has to work. So we do it with the remaining coefficients. Drop the 1. We get a negative I. Now, this second part, it works out super awesome. This works out great because everything's just going to cancel out. So the i's cancel. We get negative 2. Then we have negative 2 times negative I is positive 2I squared. That's going to give, right?
Yeah.
Oh, no, sorry.
No, negative just negative 2I.
Just negative 2I. Very good. Thank you. Or positive 2I.
Yeah.
It's negative 2 times negative I is positive 2I. The 2i's will cancel. We're left with 26. Now we have 26 times negative I gives you negative 26I. Those cancel. 0 remainder. So now we know we did it right. So that means x equals negative I. X plus I is our factor. So we have, now here's what we got. We've got x minus I from the first one. We've got x plus I from the second one. And now we've got a remaining, which is x squared minus 2x plus 26, which we're going to have to use what if it doesn't factor? Quadratic formula. And the first step is always to figure out what all the zeros are, and then you can put it back in the complete factorization. All right, so that's, we got x minus I, x plus I, and I don't think this factors, so I'm going to go right to quadratic formula with this because I can't find the factors of 26 that add up to give you negative 2. So let's go to quadratic formula. So it'll be negative b, which is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 1 times 26 all over 2 times 1. So that's going to give me x equals 2 plus or minus the square root of 4 minus 104. Oh, that's going to work out slick. 4 minus 104 is just going to be negative 100. So that'll be the square root of negative 100, which is what? 10i. So get x equals 2 plus or minus 10i over 2, and we can divide a 2 out of everything. So we're going to get x equals 1 plus or minus 5i, and there's our other 2 complex conjugate. So now we have x equals I, x equals negative I, and x equals, these are all the zeros. And that makes sense because there should be 4 of them. 1, 2, 3, 4, and it has to add up to the 4th power. So now this is the zeros. These are the zeros. And you would know because all the zeros are imaginary, this graph would never cross the x-axis. So it'd be like a x to the 4th one that's all, it looked like this. It'd be above the x-axis but never cross it. Okay? Now we write it in the factored form. So you write f of x or p of x, whatever you want to use. F of x is fine. And you're going to go x minus I, x plus I, and then x minus 1 plus 5i. And then, I'll move this over a little bit. And then x minus 1 minus 5i. And there it is. That's a factored polynomial. Okay, so that's, and this right here, that theorem is on page, I think it's on page 290. Page 290, the complex factorization theorem, which just says you can multiply them all, including multiplicities. Okay, so this right here, that's page 290. The complex factorization theorem. All right, 48. This is the one we tried to do in class, but I screwed up. So x minus, or negative 1 plus 2i is automatically a root. So then its conjugate has to be a root. So negative 1 minus 2i. So both of these have to work. All right. So we're going to do this right this time. In the box goes a negative 1 plus 2i. And if you have the one from class, you can copy it down and see what I did wrong. So we got a 2, a 5, and I'm gonna give myself more room because I know it's gonna be a lot of room. 2, 5, 13, 7, and 5. If you can get through this and get the remainder 0, the second part when you use the conjugate will be easy because everything will cancel out. All right, here we go. We'll go slow. 2, drop a 2. If I multiply by 2, I'm gonna get a negative 2 plus 2i. No, plus 4i. See, I already screwed up. I'm on a bus, so I can take a little bit of... All right? Is that right? Negative 2 plus 4i. Keithan's going to check me. 3 plus 4i will be what you get when you add it. Now we're going to have to FOIL. So unfortunately, that's the rough part. And if you need to get scratch paper out to FOIL, I'm only going to have one of these. And it's probably going to be a little bit easier than this. It's probably going to be more like 47. So it's going to be FOIL. It's going to be negative 3. If you do first, so I do firsts. Then if I do the outer, I get negative 4i, the inner 6i. Negative 4i and 6i be plus 2i. Do you agree with that?
Yeah.
Just, okay, then the last would be 2i times 4i is 8i squared. Do you agree with that? 2i
plus
times
8i
4i.
squared?
Yep, 8i squared. So that's going to give me a minus 8, right? So I'm going to have a negative 11, 13. Oh, that'll give me 2. That was my mistake in class. Negative 3 minus 8 is negative 11. 13 minus 11 is 2. That was my mistake in class. I didn't have a 2 there. Then I FOIL. I'm going to have a negative 2 for the next one, a negative 2. And the outers is going to be a negative 2i. The inners is going to be a 4i. Negative 2i and 4i is positive 2i. And then I'll have a 4i squared. Do you agree?
Yep.
That'll become a minus 4, so that's minus 6. 7 minus 6 is 1 plus 2i. Is that better? Yep.
There you go, yeah.
And then now the last foiling would be negative 1. Then it's going to be a minus 2i. Then it's going to be a plus 2i. And then it's going to be a minus 4i squared. There it is. It's going to work now. The 2i's cancel. I get a plus 4. Do I get a plus 4?
Yeah, because you're squared there.
And I had a negative 1, right?
Yeah.
Shouldn't that be a 5?
Wait, that should not. Yeah, that should be like that should be a 5.
Okay, where did I mess up? Let's see here.
2.
Looks right.
It was the third step that we messed up last time. It was this one right here. On the 7 is when we messed up last time.
I'm not sure. It's just over by the elementary school, I think. All right, let me check it again. Let me check my math. Drop the 2. We went negative 2 plus 4i, so it gives us 3 plus 4i. Then that's going to give us a negative 3. It's going to give us a negative 4i and a positive 6i, which gives us plus 2i. Then we get a plus 8i squared, which becomes minus 8. That gives me 2 plus 2i. That's correct. Then we get a negative 2.
This is where that's the step we messed up last time.
Okay, so here we go. Negative 2. Oh, there it is. No, that's right. Negative 2. Then we get a minus 2i and a plus 4i, which gives you a plus 2i. And then we get a plus 4i squared, which gives you minus 4. So that's right.
Yeah.
So that gives you minus 6. 7 minus 6 is 1. 1 plus 2i. Negative 1 times 1. It's negative 1. Then we get a minus 2i, right? Then we get a plus 2i. And then we get a plus 4. Oh, it's a plus 4i squared. It's a plus 4i squared. That's it. Plus 4i squared. And that'll make it minus 4. There's the minus 5. Now we got the remainder of 0. Now you take the other one. Negative 1 minus 2i, and everything should cancel now. Nice. Yeah, I need to be over there. Yeah. So drop the 2, and it'll be a negative 2 minus 4i. The 4i's are going to cancel, so you get 1. Multiply by 1, I get negative 1, right? Minus 2i. The 2i's cancel, and I get a 1. Multiply by 1, I get negative 1 minus 2i, and I get my remainder 0. There it is. So now I've got x minus negative 1 plus 2i. Right? And then I've got x minus negative 1 minus 2i. And then I have this 2x squared plus x plus 1. And you can do that with quadratic formula.
Yeah.
And finish it and factor it.
Sweet.
There we go.